Hello everyone, welcome to this full STL in C++ tutorial. So I think it's like nearly a 2.5 hour video. So first let me explain you what I will be teaching in this video, okay? So these are the topics that I will be going to code and teach in this video. So I have divided this video into 16 parts, okay, and I have also given the timestamp for each chapter in the description, and you can just go and watch your preferred topic. So first I will be just starting off with what and why to learn STL, and then I will just directly jump into coding, okay, coding and showing you live demo of what is vector, iterator, set, map, queue, stack, deque, and I will also recommend you to just live code simultaneously while you watch this video for better understanding. And I think if you watch this entire video, you will have all the prerequisites to start competitive programming. So I'm done explaining the introduction. Just enjoy the video. So first, let's begin with the question, what is STL? So STL is a library that provides us algorithms, containers, function, and iterators, okay? And the full form of STL is standard template library, okay? Apart from this definition, I will just give you a simple example. So in C++, to find the square root of a number, we will be using sqrt function, right? And for using that function, we will be importing the header file as include cmath or math.h, okay? Same thing in STL as well. We will be using the as include bit/stdc++.h, and then we will be using the vector, queue, stack, etc. So simple, STL is just a library, and we will be just using the functions, containers present inside STL. So this is the definition of STL, and next we will be going why to learn STL. So these are like the two reasons why you need to learn STL. First thing is that it reduces code size and saves a lot of time. So let's suppose say that you want to sort an array, okay? So bubble sort is like the easiest sorting method, but it is in time efficient. So even though bubble sort is easy, it takes like around 20 lines to execute. But in STL, with the help of sort function, we can just sort an array by one line of code. So basically not only saves you time, but also code size as well as the error, okay? So in case if you type it manually, there are high probabilities that you may like do any logical error, but STL just removes them completely. So this is the first reason. And second reason is CP, which is competitive programming. So it's obviously you'll be knowing that it's the base to get placement in colleges. So you will be asked to solve around like 5 to 6 problems within an hour. So you won't be having any time to do that. And to solve problems in a quicker way, STL comes in really handy. It is like a mandatory thing in competitive programming. Without STL, you can't do CP by using C++. So these are the two reasons. So now we are done with what and why to learn STL. So now let's just get started with vectors and let's begin to code. Hey, hello everyone. So in this video, I will be teaching you vector. So vector is a STL container. So this is going to be our first video in STL playlist. So let's get started. So here I have here a empty program with dash include IO stream and using namespace and an int main. So for using vector, we need to include one of these two header files. Okay, first header file is going to be hash include bit/stdc++.h. This basically includes all the inbuilt library functions, all the containers, all the algorithms. So I wouldn't recommend you to include this header file if you are only using vector in your program. Okay, so you can only include hash include vector. That's it. Using this, we will be able to use all the functions of vector. Okay, so you don't need to include this entire thing if you are using only vector in your program. Okay, or if you are using like many inbuilt functions, STL functions, means it's better to go with the whole thing. Okay, so let's get started. So first let's discuss what is a vector. Okay, so vector is like best definition is vector is a dynamic array. Okay, so when you're declaring an array in C++, you will be putting int arr, and if you aren't sure about the size, okay, if you aren't sure about the predetermined number of elements in the array, you will be going with random 100,000 as a value. Okay, this can be avoided in vector because vector is dynamic in nature, because it takes on the number of elements as you go on adding inside it. So the syntax for defining vector is vector, the data type, and a name. That's it. Here we'll be having a data type, so you will be putting int. Okay, let's consider int vector. If int string character is going to come inside it, and this is the name of a vector. Same thing as naming a variable. Vector, this is the syntax, and v. Okay, so how we can add elements inside a vector? That's also really simple. You are going to have v dot push underscore back. We are going to pass the variable. If you are getting input from the user, just get the input and pass it. Here I will be putting 1. So 1 will be pushed, and I will copy this and I will paste it. I will put 2. Next line, I will be putting over here 3. So that's it. So now we have got it will be stored in this form. Okay, you can just imagine it will be stored like this: 1, 2, 3. Same thing as everything is same related to array is common to vector as well. So now how to display the output? For displaying the output, it's same as for arrays as well. You will be using a for loop, iterating through each element and printing it. So that's it. Same I equal to 0. Here we are having like 3 elements. Okay, so our I will be less than 3. Okay, I will show you how we can avoid that. I is less than 3, I plus plus, and C out we are having V is the name of our vector, so V of I. Just give some space in between the elements and print it. So instead of using this I less than 3, we are manually assigning the size of the vector. We can use another inbuilt function to know it. I will just show this output and show you what is the function. So if I just compile and run, I'll be getting the output as 1, 2, 3. That's fine. And now to avoid this, okay, what we can do is there's an inbuilt function. Size is the inbuilt function. Okay, it's C out, and C out it's V dot size. Okay, and here let us have another C out elements are, and now let me just run and show you. So we are getting like 3. Okay, I will put an endl over here. So as you can see here, I am getting the output as 3, and then the elements are. So this 3 is basically v dot size. Okay, this can be really helpful when you aren't sure how many elements are pushed inside your vector. Okay, so instead of assigning this manually, here you can replace it by v dot size. So you can even store this v dot size to like this one. Okay, like int s equal to v dot size, and here you can replace it by using yes. That's it. Same thing. You'll be getting the same thing as the output. As you can see, the elements are same thing. We're getting the same thing, 3s size as the output. That's fine. Okay, now let us go how we can get the input, like this input elements from the user. That's also the same process. We just delete it and let me just copy this for loop. So instead of using this I, we can also use iterator. Iterator is also present in it's on one of the 4 components of STL, but I prefer using for loop because it's much more simple than iterator. Okay, so same thing we will be having like this. So it's just put C in element and let us get a int element. Okay, and just push that element again. So it's going to be v dot push underscore back element. That's it. But here we can't assign yes because we deleted it. We don't know the size. Okay, so you can just have like 5 elements. Okay, 5 elements I'm pushing into element, and here we can have v dot size. So now let me just write. We are going to get 5 elements input from the user. So it's going to be 1, 2, 3, 4, and 5. And as you can see here, we're getting that is the output. So that's fantastic. And our next thing, what we are going to do is, what if we wanted all the elements in a vector to be like 0? Okay. So for that, what we can do is, we just go over here int v, and you can just add the number of elements that we want inside our vector to be 0. Suppose if I wanted to be 5 elements to be of in a vector to be 0, means I can just put a 5 in a bracket. So this means that our array, our vector will be like this. It will be 0, 0, 5 times. Okay, these are the elements. This using a single line we can do this. 5 elements will be 0. If you don't believe, I will just see out v dot size as well, and I will just put a for loop and print everything. 1 to 0 I less than v dot size I plus plus, and C out v of I, and just put some space. Just execute it, and okay, so this 5 corresponds to the size. Okay, and this 5 corresponds to the elements. Okay, you're having 5 because 5 zeros. Okay, that's fine. And another thing, suppose what if you want like the number of times any particular number in an array, sorry, in a vector. So like if you want like 5 ones, okay, like this. You want your vector to have like this by default. You don't want to use a for loop or get input from the user, push back 5 ones like that. What you can do is you can just put a comma in it and add 1. That's it. So now we will be getting the same size, but all the elements will be 1. As you can see here, we have 5 ones and the size is 5. So if you want like any number, you can add. If you want 500s in your vector, you can just go this, and instead of getting input, instead of pushing it manually, like you can just do it. So these are some of the cool features that vector has. And next thing, suppose if you want to resize your vector, okay, you want to change your vector size. So now our size is 5 and it has 500s in it. And suppose if you want to resize your vector only to 3 elements, just remove all the next 2 elements. So for that, what's the syntax is that p dot resize, just pass how many elements you want. I want only first 3 elements, so I'm passing it as 3. So now here we will be again I will put a v dot c out. So v dot size c out after resized endl. Just copy it, paste it. So let me just run it, okay? It can't be put there, sorry. Just okay. Let me just run it. So as you can see here, first thing, our array, our vector was having 500s in it. So totally our vector size was 5. So that's this line corresponds to that one. V dot size corresponds to 5. So after then we are resizing our vector to 3. So after resized, then we are printing v dot size. So as you can see, our vector has been resized to 3. And here also, instead of 5 elements, we are getting only 3 elements because our v dot size has become 3. So this is one way of resizing our vector like manually. And the next thing what we can do is we can get the front and back element, okay? So we just clear all this. So by getting the front and back element, let me just assign another thing I didn't tell you. You can just assign a vector also like manually. So you can let me just put 1 2 3 4 5. That's it. So if you just run it, okay, I'll be getting the output as 1 2 3 4. This is similar to array, same thing as array, okay? So let me show you now how to get the front and back element, okay? I'll put c out front. That's also so simple. It's going to be v dot front. That's it. We'll be getting 1 as the output. And for v dot back, which is the last element, back, we are just going to put back. So this thing can also be accessed by using v of 0, and this one last element by using v dot size minus 1. Same thing, but we have inbuilt functions for that also. Instead of typing that, we can just use this front and back, okay? So as you can see here, I'm getting front as 1, back as 5 over here. Simple. And there's another thing, okay? What if we wanted to clear our vector, okay? Like, so now we have 5 elements in it. Suppose what if we wanted to delete all the things? So there's a function for that as well. It's v dot clear. That's it. So now if I just, after clearing, if I just see out v dot size, okay, we just have a endl over here. Okay, same thing. I'm just printing all the things and then clearing it and then checking the size. We will be getting the size as, yeah, I didn't add it. We will be getting the size as 0, okay. So as you can see here, this is 5 elements. After printing, then I'm putting an endl and then I'm adding v dot clear, then I'm couting v dot size. So as you can see, after couting, I'm getting the size as 0. That means basically our vector has been fully cleared. So this is the trick to empty our vector. So now if you want to check whether our vector is empty or not, okay, there is also a function for that. So let me just remove this. If v dot empty, that's our function. Cout empty. It's just simple. I think you can guess seeing the if statement itself. Cout as elements. So it's really simple. V dot empty returns true, okay? V dot this returns 1, okay, 1 that is true if our vector is empty. 0 if vector has even one element, okay, has elements. Simple, that's the thing. So if it is 1 means v dot empty is 1, our if condition becomes true and this cout empty gets printed. And if the vector has some elements 0, so it gets completely replaced by 0, that is our if condition is false, then it goes to the else part and our cout has elements will be printed. Simple. So now in our case here we are clearing our vector, okay. So in this case we will be getting the output as empty, okay, because of this v dot clear. So as you can see here, we're getting the output as v dot empty. V dot empty is true, and this empty is getting printed because we have done v dot clear. So now, what if I just commented this line, and if I just run it, as you can see here, it has elements. So simple. V dot empty. That's the thing. So it basically covers all the things that you can do for competitive programming. That's the fun part of our vector. Just if you're just dependent on vector itself, like you can cover more, at least 50% of the competitive programming only by using vector and its inbuilt functions. So next thing is pop back, okay. So pop back basically is to like pushback is to get the input and pop back is to remove the element, okay. I'll just copy this and paste it over here. V dot pop back. So as you can see here, it just removes the last element pop back. So if I just put it some trace, okay, our last 3 elements 3, 4, 5 will be removed, okay. We'll be getting the output as only 1, 2. That's it. So simple. It just removes the last element. So we have done with now front, back, push back. Next thing is clear. We have done. So only 3 are left. That is insert, erase, and remove. Okay. So if for inserting, we are having like this as a syntax. Okay. V dot insert position and the element. Okay. This is basically the syntax, okay. And another thing that you take into notice is that in vectors we can't just give the position by using a number. We need to give by using an iterator, okay. That's the only way we can give position in vector. So how it is done is that v dot begin, okay, v dot begin. This is like a iterator reference to the first element present in a vector. So v dot begin will be basically v of 0. This corresponds to the address, okay, address of v of 0. If you put a asterisk over here, if you know pointers, you will be really clear over here. I've done a video about pointers, you can go and watch that. If you put a asterisk over here, this corresponds to the value of v of 0. But if there isn't any asterisk, this corresponds to the address of v of 0. Just a reference, okay, reference. Like if you have used pointers, you'll be knowing this one. And you have another reference, okay, v dot end. This is also a reference to the address of the last element, okay, v of how to write that, v of size minus 1, okay. This is the last element because suppose we here having the 5 elements over here, our this element will be 4th index because 0, 1, 2, 3, 4. So v of 4 will be 5. So this one is 5 minus 1, that is the size minus 1, we will be having v of 4. So v dot end basically is a reference to this last element. So that's what I have done here. So now what if we want to access the second element? Okay, because we are having only 2 references. This one is for the beginning, this one is for the end. So how we can access the second element is means that just by putting v dot begin plus 1. That's it. This corresponds to the second element. Okay, because this is 0 plus 1 will give us a reference to the second element. And if you put 2, this gives a reference to a third element. Same thing. You can also subtract from minus 2 like that because it will come to the third element like that. You can also come from backwards. So these are the basic tricks before going into the portion, okay. So now let's just insert something. So it's going to be v dot insert. Let us say you want to insert at the first position, okay. Let's just go with the basics. Begin and say I want to insert 6, okay. So after inserting, like, let me just print it, okay. Control C, paste it, just put a C out. After inserting endl, just execute, compile and run it. So as you can see here, v dot begin, as I told you earlier, it corresponds to the first position. So basically it has, let me just close all these things first, it's really confusing to find out. Okay, so first position, we have just marked the position v dot begin. We are, as I told you earlier, v dot begin corresponds to the 0th index of our vector. So 6 is getting printed, inserted in the 0th index, and all the other elements are not, it's not getting replaced. Insertion means basically like we're just pushing the elements to the right side, okay? Move ahead, move that way, and I need to come in this place. So that's what happening here. 6 is coming in place of 1, and all the elements are pushed towards the right. Simple, that's it. And suppose if you want, like, I want 6 in place of this 2, and 2 needs to get moved rightwards, means you can just put v dot begin plus 1. So now how it will be is that it will be like 1 comma 6 comma 2 comma 3 comma 4 comma 5. So this will be the output. So if I just run it down, so I'm getting 1 2 1 6 in the middle. And now if I show you like how end works is that, so end this won't be the output. Our 6 will come over here. Just right now, simple, we're getting at the end. So as I told you earlier, we can just manipulate this one also. So we just put a -2, okay, -2, where it will go? -2, it will be here, okay. So we just run this one, okay. So as you can see here, this position, so it comes over here, and 4 and 5 moves that way. 2 elements, just skipping, -2 means after skipping last 2, then it gets inserted. That's it. This is the insert function, okay. And this one will be used in most of the places, okay. Even for sorting our vector, we will be using that. I forgot to tell you about sorting as well, okay. Sort, same thing, we will be using this v dot begin and v dot end over here also as well. It's going to be v dot begin, that is the starting position, comma, that is the ending position, v dot end. Just put it, this will work in ascending order, okay. And I was changed the vector to some random values because it was already sorted, okay. So now if we just run it, okay, it will be getting sorted in the ascending order, okay. And okay, it's showing an error. The reason why it's showing an error, because we have only included IO stream, okay. Sorry, IO stream and IO hash include vector. So but sort comes inside this one, this hash include bit slash std. And if you are going to use only sort, it's going to come under hash include CLUD algorithm. Because when I told you in the previous video, we had like 4 components, algorithm, containers, iterators, and functors. Sort comes inside algorithm component. So we need to include hash include algorithm. So now if I just run it, I won't be getting any error. So as you can see here, my vector is getting sorted in ascending order, okay. So that's it. This time is not required. So now what if you want to sort this vector in descending order? It's really simple. You just add another one argument, okay. It's going to be greater int, and just put some circular bracket like this. So this add just this thing, and it will be getting sorted in descending order. So as you can see here, we are getting sorted. This is a sorted one, 107.5. So it's in descending order. This is for sorting, and in order to avoid this, like using hash include vector, hash include algorithm, if I just comment this out, and if I just use this one, so here we are having like 2 things, so we can just better go with hash include bit slash std c++. So we'll be getting the output. This won't show any error. That's it. So this is sorting, and next thing is removing, okay. So we are having like 2 removes, okay. And another thing as well for sorting, like what if we wanted to sort only a particular range in it. For example, if we want to just remove this first one, we want to ignore this first one, and we need to sort this range only, okay. So we need to like have our vector as 100, 1 comma 5 comma 7 comma 10. We need to get our vector like this, okay. So for that, what we need to do is, so here we aren't sorting the first element alone, we are sorting the rest of our vector. So for that, just change the position. As I told you earlier, this corresponds to v of 0, reference to v of 0, and this one's for the last element. If you just put plus 1, this refers to the starting position plus 1, so it will consider these elements only. So if I just run it now, I will put C out after sorting. Let's put an endl over here. Just execute this. So as you can see here, my first element remains same, and my rest of the things are getting sorted in ascending order. Okay, so same thing. If I want to keep this, what if like I want to keep the first 3 elements same and 10 and 5 only to get sorted? We begin plus 3. Okay, so now if I just run it, our first 3 elements will remain same, last 2 elements will be getting sorted. So as you can see here, first 3 are same, last 2 are getting sorted. Simple. So this is for sorting. We just work around with, we just do and practice, you will be getting like so simple. It's really simple how it works. So I will just comment this stuff. Okay, so next thing is erasing. Okay, so we have the v dot erase. Okay, erase is the name of to remove the particular elements between the range. So we just put v dot begin comma v dot begin plus 2. Okay, so this is the range. Okay, so just simple, v dot begin corresponds to 0, begin plus 2 corresponds to next 2 elements, so it's going to be this 3. Okay, so now let me just run it and let me just show you. Okay, I will put after erasing. Okay, just execute it now. So as you can see here, 7, 10 and 5, the first 2 elements are erased. So which means that this erases from 0 to, if you put begin plus 2, it's not till 2, it erases. 0 is considered, but 2 is not getting considered. It's from 0 and 1 are getting erased basically. So if I put 3 means it's 0 to 2, which implies 3 is not included. So it will basically erase. It basically erases the index 0, 1 and 2. Okay, so now if I just show you, it erases. If I put begin plus 3 means we will be getting removed 100, 1 and 7 will be removed, 3 won't be getting removed. So if we just run it now, we will be getting the output only as 10 and 5. So that last term is not getting included. So we will be getting the output as 10 and 5 because 100, 1 and 7 are getting erased. Simple. This is also same logic as I told you here. Simple thing, begin, just use position. I'm not using here v dot end, I'm just assigning v dot begin. You can also use this way as well because these are just positions. Okay, simple. This is v dot erase. I'll just comment it. I guess that's it. V dot erase. There are also many functions like binary search, remove is there. We have max size, capacity. There are like also many inbuilt functions for vector but I think these are like the most importantly used for any programming related stuff. Hey, hello everyone. So in the previous video we are discussing about vectors in STL C++, and in this video we are going to talk about iterators. So vector was present in the container component and iterator is like a separate component in STL. So what's the function of iterator is just to iterate throughout our container. In this case we are using vector. So it's just basically like used to display our contents present in our vector. So one of the simplest way of doing this is by using just a for loop, just assigning for int I equal to 0, I less than v dot size, and just putting I plus plus over here and just putting C out v of I and an endl. So this one we will be getting all the elements present in a vector like with the in a new line. So this is one of the common ways, and here we aren't using any iterator or STL component. So what if we wanted to use iterator component of STL? It's really simple. Okay, so first thing what we need to do is, so if you are going to include this whole header file, it's well and good, and suppose if you want to just include our iterator, okay, it's going to be hash include iterator. Okay, iterator, and here we are having vector also, so I will just include a vector as well so that it does not give us an error. So it's really simple. This is the header file for iterator. You need to include this, otherwise you will be getting an error. And suppose if you just don't want to give this like individually, you can just go with hash include bit slash, which gives entire access to our STL components. So now how to like define an iterator? It's really simple. You need to just copy your syntax of a container, just copy it, just go to the next line and just paste it. Just put 2 colon, okay. This is not a scope resolution operator. And next you will be typing iterator and it or ptr, like this is going to be the name of our iterator, and this is the basic syntax. This int corresponds to this one. It can be string over here, if then it should be string over here. If it's a vector, then it's going to be vector. So this is like a basic syntax for our iterator, and this can be like any name. So how it's going to work is that this is like a address storage, okay. Like as I told you earlier, we had v dot begin, which are like references, v dot begin and v dot end. V dot begin references to the first 0th index, v dot end refers to the last index. So these are basically address references. That is same for iterator as well. And iterator works on address of our each element, and it doesn't work on indexes. Like v of I, for you had a v of I for loop right before, that works on indexes, but iterator works on addresses. So how we can iterate is same thing. We will be using for loop over here, but we will be like iterating with the help of addresses. So it's going to be it equal to v dot, v corresponds to this vector, v dot begin, and just close it, and our terminating condition over here will be it not equal to v dot end, which is the ending pointer, okay. And here we'll be just putting it plus plus, same thing, and we'll be seeing a cout asterisk it ended. So let me just explain it clearly. It, this is like initial value, so just consider we are doing for int I equal to 0, we are initializing I value. Same thing, it we are just assigning v dot begin, which is we are giving reference to our first address, 0th index address. So here's a terminating condition. It shouldn't be like the end reference, okay. So that's the end reference, so it will run, loop will run till this one, it's not equal to v dot end. And I plus plus, we are just going to the next address, just incrementing our iterator so that you can just pass throughout all the whole vector. And here we are we printing cout asterisk it, because it is just address reference. As you know, pointers in C++, if you print asterisk of it gives the value present inside that address pointer, okay. So if you put only it will show an error. So if you put asterisk it, then only it will like will be able to access the data present inside that particular address. So as you can see, we are just getting the same output over here as well. So this can also be like shortened this way, like we can just remove this one, just remove it, and here itself you can assign it equal to like v dot begin, and if you just run it, so we will be getting the same output over here. And as I told you earlier, if you don't put this asterisk, like you will be getting an error, okay. See, it shows an error because we can't just, it's just a reference, okay, we can't be printing that. And like there are also other ways, like okay, this is fine, let me just delete it. So we can just assign it equal to v dot begin, okay, v dot begin, and if you just cout asterisk of it, okay, so we will be getting 1 as the output, because this is a reference to the 0th index present in our vector. So we'll be getting 1 as the output, which corresponds to this. So if I just put over here v dot begin plus 2, so it will be corresponding to 3 over here. So if we just execute it now, so I'll be getting the output as 3. And similarly, you can just put v dot end and put minus over here and just do with it. So this is what we can do with iterators in C++, like really simple. You can just iterate a header file and just do a vector, okay, like this, and that's it. Like you can even like avoid using iterator, like if you think it's a little bit confusing and stuff, you can just stick on with for loop as well. It's totally up to you. Hey, hello everyone. So in this video we are going to see about set in STL C++. So the previous video we saw about iterators and vectors. Today we are going to see about a container set in C++. So let's get started. So set and vector are both containers, but there's like 2 to 3 like major differences between them. So let me go show with you like the first difference. Here we are having just a vector over here. So let me just comment it, and let me just comment this header file also. So first thing, let's begin with the header file. For using set, we need hash include. From the name itself you can get, we just set. So hash include set is the header file for using set here, and the declaration is also the same over here. It's going to be set int s equal to, let's have like this 1 comma 2 comma 5, okay. This is going to be our set, okay. Just imagine, okay, Next I will come to the major differences. So now if we just put a for loop, I less than s dot size I plus plus, and we will just put cout s of I. Okay, now if we just run this code, we will be getting an error over here. So as you can see here, the reason is because the elements present inside the set can't be accessed by using indexes. We can't write s of 0 to get 1, s of 2, s of 1 to get 2, like that. So this is the first major difference. We can't access set elements by indexes, whereas we can access vector elements by using indexes. For example, let me just comment this and let's just put v over here, and if I just put v of 5 over here, and if I just run this now, I'll be getting, okay, I didn't include this header, right? Just put this. So we just run it now, I'll be getting 1 2 3 5 as output, but the same thing can't be done for set because set can't be accessed by indexes. So how to solve this is, like, we can use an iterator. Okay, so it's going to be auto is like a non-data type. Okay, auto, we will have iterator, so it's going to be auto it equal to s dot begin, and here it's going to be it not equal to s dot end, and same thing is going to be it plus plus, and here we are going to use asterisk of it because it is address, and asterisk of it will give us the data present for in that address reference. So if we just run it now, we'll be getting the elements over here. So suppose if you consider this is like really like repeating process, you can just put a for int it and just put yes over here, and you can just cout it. That's it. This is also the same syntax. So if you just run it now, we just have a endl over here, cout endl. To just run it, so we can get 2. Okay, same thing we are getting. So this is also like a shortcut method. Okay, but we can just print all the elements, but the only thing is that we can't get access a particular element by using index. Like for in case of array, we can't write s of 0, s of 1. That's the point I'm trying to make over here. So that's it. And the next comes the major difference. Okay, let me just have this one. Okay, have a print of. Okay, so now in this set we are having like all the elements are unique, like there isn't any duplicates over here. 1 is occurring only once, 2 is occurring only once, same applies for 3 4 5. So what if I applied any duplicates? So let me say I am adding here another 5, I'm adding here another 1, another 2, and another 3. So now basically our set has like these all are duplicate numbers. Okay, so if I just print it now, let me have some space for printing, like, okay, so if I just same code, I've just added like 4 numbers which are duplicates of the existing numbers. So if I just run it now, we are getting the same output. Like it's just literally the same output, 1 2 3 4 5. Only the first 5 numbers are getting printed and the duplicates aren't printed. So this is one of the properties of set. Okay, in whatever may be the like values we are putting inside the set automatically eliminates all the duplicate values. It just consists of the distinct or the unique values. Okay, so the repeated values are just eliminated, and just one instance per value. Like it's not completely removing the duplicates. For example, like if it's a 1 and 1 are duplicates, it's not completely removing 1 from the our set. It has like one value of one value of one number. That's it. So 1 occurs, it's like just a single value of a number. Okay, so for example, like if you put like hundreds of 1 also, like let me just delete this all, and if I just put 1 comma 1 comma 1 comma like this, still my output is going to be like only 1. Output is only 1. And another important thing is that let me just comment this all. Okay, and another important thing is that if you just go and type cout s dot size, okay, so we are having like what will you can guess the output. Literally you can guess the output over here. We'll be getting the output size of set s as 1. So as you can see, we're getting the size as 1. So if I just add like another element over here, we will be getting our size as 2. That's it. So all these terms are getting neglected. So this is one of the facts of our set. Basically, there are also two types of set. Okay, two types, like ignoring only set. There is like multi-set, most commonly used set. I'm saying there's uh, unordered set as well. Okay, so I will show you, like I will also explain this in the in within 5 minutes time. So these are like for the set, and another important fact is that, let me just uncomment these things. So one is unique, and another fact in sets is that set basically like automatically sorts the element in ascending order. Okay, by default the sorting is in ascending order. For example, now let just consider our set s equal to, I'll just put 1 comma 12. Okay, 1 will be 1 comma 2 comma 5 comma 3 comma 3 comma 4, and it will be pushed to 9 and 0. Okay, so consider this is our set, but in output we will be getting, I'm just putting it output, we'll be getting in sorted in a ascending order format. As you can see, it gets sorted. So by default, set basically sorts the elements present in its field. Suppose what if you want these elements to get sorted in say descending order? Simple, you're just going to put greater and int. Okay, that's it. Now if I just run it, we will be getting 9 5 4 3 2 1 and 0. As you can see, now it gets sorted in descending order. So these are like some of the inbuilt, it uses binary search tree. There is some backend process, sorting takes log of n. Sometimes there are like so many stuff, backend stuff happening for this sorting process. So to make like keep things simple, I'm just saying it's just sorts. So if you want to learn the backend process, like you can go and search the web and learn. But that's, I guess, like you can know how it works, but if you aren't interested of, you can just ignore it. That's not going to make any harm. So this is how basically cert works. And again, same thing, like if you add any duplicates, it's just going to get ignored, even it's getting sorted. Like same thing, we will be having only 1 2 now in our output. Same thing, it just gets ignored. Okay, now how to get input in set. So for vector, as you know, we used pushback. Okay, we use the pushback function to get input in like vectors. So for set, it's s dot insert. Okay, so if we can just directly put the value, let me put 1 and let me just copy it. So it's going to be like 2 and 3. So if we just run it, so as you can see, I'm putting the output as 1 2 3. So this is how basically like you can insert in our set. And suppose how you can get input by using for loop. Like it's a really simple process. Okay, so just delete it. Just first get the size from the user. Okay, so I will put int n and c in n. Okay, first I'm getting the size from the user. I'm just putting a for int I equal to 0, I less than n, I plus plus, and here I'm getting the value. Let val be the element. Okay, so it's going to be c in val and s dot insert of val. That's it. So by this way, like we can get the input of all the elements inside our set. Let me just run it now. Okay, so first n we need to enter the n input. Okay, let me have 5 elements, so I will type 1 2 3 4. So for a change I will type 1. Okay, so as you can see here, I have entered 5 elements over here as an input, but I'm getting 4 elements. So you know the reason why, because I have entered 1 twice. So set should not contain any duplicate, so it basically ignores the last one that I have typed. So I'm getting 4 elements as the output. So this is how like you input the like any elements inside set, and this is how you print it. So these are like basic functions happening over here. Now let us go, and all the other functions like erase are common. Erase is common. Like clearing the set. For example, let me just clear a set and show you. So let me just remove all these things. We have set s equal to some same 1 2 3 4 5 over here, and if I just clear, say s dot clear, okay, it just clears it. So now we just put cout. Okay, cout set size is, so I will just copy the same thing over here. Let me just paste it over here. Java yendl. Okay, that's fine. So I will show you how clear works. So now I will just write down. So as you can see here, this is this first one. Okay, first here I am printing like set size is 5, so we are getting 1 2 3 4 5 and 1 3 4 5 gets printed. And next thing we are just doing s dot clear. So once we have done s dot clear, it just removes everything inside our set and our set size becomes 0. Simple. It's the same thing for syntax as vector as well. Same syntax as in vector. So same thing applies for set over here as well. So another thing what we can use is for like erase function. So for erase function also is going to be like same as in case of vector. So let's do the erase. So it's going to be s dot erase. We just put s dot begin and we'll just delete the first one. Okay, so now I'm just running it. It's just deleting the first element over here. So it's simple. Okay, so with the erase and same thing erase and stuff. So same in case of like vector. Okay, so I've discussed it over there. Now let's just move on to multi-set. Okay, multi-set and another set. So for multi-set also it's just the same. If you just put multi over here, multi-set, that's it, same thing. But the only thing that differs over here is that we can have like duplicate values in our multi-set. Okay, so now just remove it. So we just put here 1 comma, here we put 1 comma 2 comma 2, so that is 21. Okay, so we're having like two duplicates, one is repeated twice, 2 is repeated twice. So if I just run it now, so as you can see here, it's getting sorted in ascending order, so that sorting condition isn't going off. But as you can see here, my repetition is allowed over here. So duplicates are allowed in multi-set, but the elements are getting sorted. Okay, so same thing, you can just put greater inside it, so and sort it, and all other functions are same. Okay, all the inbuilt functions are just same for our multi-set as well. So this is for multi-set, and next one is unordered set. So as the name suggests, you can get it. Unordered set does not have any like sorting. Okay, it's going to be unordered underscore set. Okay, so we can just remove this one. Okay, same input. I'm having duplicates 1 and 2. So if I just run it now, we aren't getting in a specific order. It's not sorted in any ascending or descending. But as you can see, we aren't having any duplicates over here. So another set basically just randomly like assigns our number which is in getting sorted. Another set is like if your purpose is just to remove the duplicates and your purpose isn't to like to get sorting, because set insertion function will take more time than unordered set, because set needs to sort the element, so it will take some time for the element to just find its position sorting. But unordered set, as you can see, it doesn't sort. So unordered set is like really quick in insertion process than set. So when your purpose is just to remove the duplicates, when you don't worry about this whether the element is sorted in and stored, you can just use unordered set over there. Another important thing that I need to tell you, like for unordered set, it's not present in set. Okay, so you need to like include a separate header file. If you aren't including bit slash, you hash include set. So now if you just run it, so if I just run it now, we'll be getting our output. Okay, so this is header file for another set, and for multi-set, like we can just use our set header file itself. There isn't going to be any change. Just put multi-set over here, and if you just remove this, our multi-set will be working over here. That's it, it's working fine. So that's it for this video. I hope you would have had like a good understanding about set. So same thing for operations as we are algorithms as well. You can also use sort, find over here. That's just the same thing repeating for over here. So you can just go and watch vector and you can just get a good idea about set as well. Hey, hello everyone. So in this video I will be showing you how to implement binary search by using only one line. You are right, only one line of function by using STL in C++. So this is like the binary search entire program. So we have like nearly 42 lines of code. So I am going to show you how we can implement this 42 lines of code by using a simple one line function, that is with the help of STL. So Here I have here like a simple vector over here. Okay, so for binary search you can know the input array should be sorted, and then only we can apply binary search. Otherwise, like we need to sort the array or a vector, and then only we can like perform binary search, because it works on the principle of eliminating the higher and lower values of the midterm. Okay, comparing the middle and the number we are searching. So first thing what you need to do is we need to include the header file. So you can include like the entire thing as well, and or if you want only to include the thing for binary search, we can do with as include algorithm. Okay, so this is the header file for binary search. So here I'm using vector, so I will just copy this and I will put for vector. Okay, it's fine. So for binary search it's like really simple. What we are going to do is just put cout. It's going to be binary underscore search. Okay, so before going to that, before in the previous video I have said you that like there are 4 components in STL. One is like containers, algorithms, functors and iterators, and this binary search comes inside the algorithm component, so that's why we are including algorithm. So here it's like we will be passing the let me just write the syntax first. Okay, it's going to be binary underscore search start position, end position, and the element that we are searching. Okay, this is the syntax, and these positions are we are going to give by using the address reference or the iterator. That is here it's we are using v, so it's going to be v dot begin, and here it's going to be v dot end, or like anything v dot begin plus 1, and this can be also like v dot begin plus 5. It can be anything, but we will be using only iterator or address reference positioning over here, and this is the element that we are going to search. So this is the syntax. So let's do it over here as well. So I'm going to put v dot begin, and here I'm going to put v dot end, which basically that means that we are like scanning the entire vector. Okay, it's the position is from starting position of a vector, that is 0th index till the last index, and let's search here 3. Okay, and my vector is sorted. I am just giving the input vector sorted in ascending order itself. Like, so only if the vector is sorted or array is sorted, I will show you array as well in next example, we can perform binary search. So sorting, like, it's really important. Okay, so now let's check the code over here, because I'm just given binary search without begin, without end, and the element. So if I run it now, I'll be getting the output as 1. This means that my element that I'm searching is present in the vector. So it does not give the index of the element. Okay, present in the vector, it just gives the whether element is present or not. So true or false, basically 1 represents the element is present in the vector, and 0 will represent the element isn't present in the vector. So if I just put 7 or 9, put 7. Okay, so now if I just run it, I will be getting the output as 0, which means that my element isn't present in the vector. So for this, like, you can just place it inside of if condition. Okay, just place it inside a if condition over here, and can just put over here, can just cout found, else can just put else, and cout not found. Okay, so for linear search the time complexity was big O of n. Okay, for binary search the time complexity will be always big O of log n. Okay, log n time comparison. So here also the same time complexity, because it will perform some backend function. So the only advantage is that the time complexity is going to remain the same, whether we are using this code, this full code, or we are typing this single line. The time complexity is going to be log n itself. The only advantage is that we don't want to like this 30 plus lines of code. This 30 plus lines of code can be just replaced by this single line. That's the main advantage over here. So if I just run it now, so I'm putting 7 over here, so we need to get the output as not found. So I'm getting output as not found. So if I put any number present in, I'll put 3 over here. So if I just run it now, I'll be getting found. Simple. So now I will show you this same example for an array. Okay, how we can use it for an array. So for array, it's going to be int. Let ARR be our array. ARR of, let me say, size of 10. So let it have the same elements over here. It's going to be 1, 2, 3, 4 and 5. So same. So for array we can reference it by using this one. Okay, so it's going to be ARR comma ARR plus the number of elements. So here we are having 5 elements, so it's going to be ARR plus 5 comma and the element that is going to be searched. So let us search 4 over here. So this is the syntax, okay, for using it with an array. So I'll just copy it and I will just comment it out. This is the syntax. So this corresponds to the address reference of the 0th index. Like when you are like storing a particular pointer, anything like if you are putting int asterisk ptr equal to ARR. So this basically corresponds to the address of the 0th index, okay. So that's what, same thing, this is the address of the 0th index and ARR plus 5 will represent the last index. So we're just passing reference address references here also. We can't give like positions over the index like. So now if I just run this code, so we'll be getting found over here, found. So you can ask me why we can't put ARR.begin and you can put here ARR.begin. It will definitely show an error, okay. So let me just try that also. Okay, it will definitely throw us an error over here. It throws an error because ARR isn't a component of STL. Vector is only a component of STL. So there we can be using, so vector only we can use v.begin and v.end. So this is for like for arrays. You can use this with arrays, vectors, anything you can use this function. So another operation as well. What if our vector isn't sorted at first itself? So let's do that as well. So I will just change it to v.begin. Just change it to v.end and we just put a number of 10 over here. So okay, so I'll just change my input vector. So I'm changing it to like 2, 10, 30, 500, 1, 0. Okay, so this is like random numbers that are not that are in sorted in ascending or descending order. So what will happen now is that if I just run it now, so we are searching 10. So if we are lucky, we may get the output as 1. Okay, it's showing not found. So it's really simple. So but 10 actually is present in the vector. So here our binary search fails. The main reason is that our input vector isn't sorted. So you can't expect the binary search algorithm to first check whether our input vector array is sorted and then search. It just searches it, okay. It's our responsibility or duty to first sort our input vector or our container. So we need to just sort it, okay. So for sorting it's like really simple. Sort of v.begin comma v.end plus 1, and for arrays also it's going to be the same thing. So for array it's going to be sort, so we'll just replace it by this thing. So we can just replace this by this code. This is how to sort array, the first reference and the last reference, that is plus the number of size of the array. This is, so now we have sorted our vector successfully and now we are putting 10 over here. Same thing, I've just sorted my vector, so now we'll get the output as found. So another thing what we can do is we can like change the position over here. So let me just comment this as well. So let me just change it to a sorted one, okay. Let me put 1, 2, 3, 4, 5, 6, 7, 8, okay. So now what I'm going to do is I'm going to search a number within this range, within these 5 numbers. Let's consider, okay, 5 numbers. So it's going to be v.begin plus 5. This corresponds to 0th index till the 5th index, I guess, 0 till the 4th index. Okay, sorry, I'm sorry, till the 4th index. So it's going to be 0th index, 1st, 2nd, 3rd and 4th index. So this is our range, okay, that is from 0th index till the 4th index. It's not till the 5th index. 5th index will be excluded. If you put plus 5 means it basically refers till the 4th index, okay. So this is the range. So if I just put 4 and right now let me put just 5, okay, that will like clearly show us the border. So if I just put 5, it is the last element that we're considering, so it's found. So this is till this one. So if I just put 6 now, it will show not found. That's it. So it's really simple, okay. Even though our 6 is present in our vector, here we have specified a range, so it just works based on our range. Hey, hello everyone. So in this video we are going to see about map in STL C++. So in the previous video we saw about vector, binary search algorithm and set in STL. So here we are going with maps. So what is map basically is like, it's like a storage for like key and value pair, okay. So consider like you're having a key and there is a value, okay. So it's not going to be like an individual element. Like for arrays, we have the 0th index will be having only one value, but here in the map, 0th index will be having a key and its value. So we can access this value only by using this key. Okay, and a map can have multiple of those. Okay, so it can have like a key value, and it can also have like many key values. Okay, so this is basically a map, and how we will represent is that. So let me show you an example. So consider let M be our map. So it's going to be like in the form of 1:2. Yeah, this is just a representation. Okay, this isn't how it looks, but I'm just showing you as an example. So it's going to be 2B and 3C. Okay, so now if you print m of 1, okay, so if you just print m of 1, we will be getting the output as a, because 1 is the key and a is the value. And if you put if you just print m of 2, we will be getting b as output. And another main thing is that this 1 doesn't refer to the index. Okay, it doesn't represent the first index or 0th index. 1 represents the key present in that particular map. So this is how it works. If you print if you put m of c, we will be getting c as the output. That's it, very simple. And map are also called as dictionary. Okay, if you are familiar in by using Python, it's known as dictionary in Python and hash map in Java. Okay, now let's come to the C++ part. Okay, so let me just delete all those. So in C++ we have like 3 different types of map. So one is a normal map, and another one is the unordered map, and another is the multi-map. So each one has its own purpose and its own usage. So unordered. So let's get started with the normal map. Okay, so for map we need to, like, if you are only using the map map library or a map function, how will we include it is going to be as include map. That's it, map, sorry. So if you don't want to like include this one alone, you can just go with this one. It's not going to be an issue. And now I will show you like how to input values inside a map. This can be done both like from the user as well as manually. So I will show you both the methods. So first I will go with the manual one. So it's going to be map, and as I told you earlier, map is going to have a key and a value, and this key can be of any data type, and this value can also be of any data type, and it can be, and both can be also of same data type. That's not going to be an issue. So first I will show you here both the int as well as int map. Okay, so both our key and value is going to be a integer of both of integer data type. So let m be the name of our map. So how to initialize that, we should not use here equal to and just put this one like this curly bracket and initialize that we are doing for vector as well as array. So here we won't have this equal to sign itself. So it's going to be like, I'll put 1 comma 10 and just copy this, put a comma over here, paste it, and I will change it to 2 comma 20. Then I will put comma and I will put 3 comma 30. So this is my map. Now this is how you initialize manually values. So here 1 is the key, 10 is the value, 2 is the key, 20 is the value, 3 is the key, and 30 is the value. So now I will just print and show you. Okay, see out, I will put m of 1. Okay, so if I just execute it now, so I'm getting the output as 10. Okay, so as I told you earlier, this m of 1 does not refer to the index. Okay, it's not like the 0th index, first index. So if it were the first index, means we would have got the output as 20, but it's not that case. Here we are having key. Okay, so now I will just put some other like random values. So it's going to be like 50, and here it's going to be 100. So we just print m of 50. So this 50 corresponds to the, not the index, but this 50 key. Okay, so in map, that's the main difference, major difference, everything. Here we will be accessing only with the help of key, not the index. So you have to be very really cautious about that. So if I just execute it right now, I'll be getting the output as 100. So I'm getting the output as 100. That's fine. So this is how you like declare it manually. So now I'll add some more values. Okay, let I add the same key itself. Okay, so it's going to be 1 comma 20. I will put 1 comma 40 like that. So as you can see here, this one key is repeated thrice. The value can be anything, like the value can be like anything. I am just using having my key as the same key. Okay, so this is my map now. So how many elements are there in this map? This is 1 element, 2, 3, 4, 5 and 6. So we are having like 6 key and value pairs. Okay, this is 1 pair, 2 pair, 3 pair, and like we are having 6. So now what if I put m dot size? Okay, I'm getting the output as 4, and the main reason because I'm getting this output is that in normal map, that is this normal map, we can't have any duplicate keys. Okay, we can have duplicate values, like we can have 10 for all the values, but we can't have duplicate keys. Duplicate key in case like here we are having only 3 ones. Okay, so this is a key, this is its duplicate, this is its another duplicate. So what map does is that it just neglects these two. So okay, so these two are neglected. In that case, we will be having only 4 key and value pairs. That's why we have got the output as 4. These two, because they are having the same key, one already one is present. So these two are just getting neglected, and we are getting the output as 4. So if I just change it to some other key, I will change it to we are not having 5, we are not having 6 as well. So if I just change it, and I will just have the same value. Okay, so 100 is already there. I'm having 100 here as well. 20 is already there, 20 is here also. So if I just run it now, I'll be getting the output as 6. So I'm getting the output as 6. So the only constraint is that in normal map, okay, in multi-map we can have duplicates. We can basically like have any like same key for many key and value pairs. But in normal map, we can't have duplicate keys. We can have duplicate values. So here we are having 6, but we are having duplicate values 20. 2 and 5 key has values 20, and 50 and 6 key has value 100. But that isn't going to affect our map. So this is the logic. Map can have duplicate values but not duplicate keys. So we have done with the size and we have just initialized. So now I will show you like how we can iterate throughout this map. Okay. So for iterating, we just put for auto it and m. Okay. So this is the variable name. This is the auto like data type, and this is the name of the map m. And we just put a curly bracket cout. And here is the fact, like here we are having two values. Okay, a pair has two values, a key and a value. So how we can access that? If we put it dot first, okay, we put cout it dot first, this will correspond to all the key present in our map. So it will come 1 2 3 50 5 6 will be printed. So I will just print this and show you. I'll put just a mdel. So if I just print it now, I will be getting all the keys present in our map. So as you can see, I'm getting 1 2 3 5 6 and 50. And another important thing is that all the keys are sorted. Okay, so as you can see here, all the keys are sorted over here. And this is another thing, map also sorts all the keys. So it just sorts all the key in ascending order. By default it's ascending order, like set as well. Set as also default of ascending order. So all the keys are sorted over here. So now what if we go with what if we want to print this value as well? We'll just go over here and I'll just add some space. I'll put it's it dot second. That's it. So this is how we are going to access our key. This is how we are going to access the corresponding value. So we just execute it now. Our values are getting printed. But here we have like this perfect ascending order over here as well. So now I will just like have some change. I will put this 3 as I will just put it as some 1000. Okay, I'll put it as 1000. So now I just execute it. So we can see here that 3 is coming over here. So this means that when we print our key and value together, it's basically sorting based upon the value of the key. It does not care about the value present in that value. Okay, it's only caring about sorting based on the value present in our key. So basically on 3 is getting sorted. So if it were sorted based on our value, 3 should have been like the last element because it's basically ascending order. So this is the highest value, so this should be at the last. But if I just print this one alone, okay, I'm just printing the values alone. I don't know like what we are going to get the output. Just printing the values, and it's the same here as well. Okay, so it doesn't sort on the values, it only sorts based on the values that are present in keys. That is the key. Okay, it sorts based on keys. Okay, to be more precise, it sorts based on this one. Okay, this 1 2 3 to be precise. That's it. So now I will show you like how we can use iterator to iterate throughout this. So it's really simple for iterator as well. So you'll just go here and include include iterator and just copy this one, paste it, colon iterator. I will name it as IT as IT itself. So it's going to be for IT equal to m dot begin IT not equal to m dot end IT plus plus, and it's going to be C out. We need to put asterisk IT, okay? As I told you, it's address reference. To access the value present in address, we need to put asterisk. So it's going to be asterisk of, so it will be first, just put some space, asterisk IT dot second, handle. So if I just execute it now, so it's showing okay. So we need to put this asterisk IT inside bracket, okay? So asterisk IT and this asterisk IT second also inside the bracket, okay? So just right now I won't get that error, so I'm not getting the error, and just prints in our ascending order. So what if we wanted to do that in descending order? What if we want our map to get sorted in descending order? So for that it's going to be like we need to put greater int over here. So if I just run it now, so as you can see here, our map is getting sorted in descending order and gets sorted upon the key. Okay, so as you know, 50 is highest key, so it comes. It doesn't care about the values. It only sorts based on the key. Okay, so this is how we can like declare a map and initialize values manually and just iterate and display the key and values. So now I'll just go and delete this one. Okay, so we can also add values like this way. You can just put m, which is the name of our map. I'll just put m of 1 equal to 10 and m of 20, say I will put it as 200. I'll just display it now. I'll just say execute, compile and run it. So we'll be getting like key and value. So this one is basically our key, and this 20 is also a key, and this 10 and 200 are its corresponding values. So you can also do it this way, and you can also have like m dot insert. It's going to be m dot insert of, just put a curly bracket like this and just add 1 comma 20 there, and I will just copy it again, paste it. I will put 2 comma 40. So I will just execute and compile it and run now. Can get the values. So I will just do this like another 3-4 times. Okay, so we have like 3, say 4 and 5. Put 30 over here. I'll put 34 over here. Just change the values as well. 48, 50. Okay, it's fine. Let's have a duplicate as well. Let's have one same. Okay, so if I run it now, we won't be getting 2 ones in the output because one normal map does not allow any duplicates. So there is any duplicates over here. So now let's go with the unordered map. So how to change to unordered map? Really simple. You need to just go over here and type unordered underscore map, and you need to just copy this one and just paste it over here. That's it. So let us now run and see how unordered map works. So it's really interesting. These are getting printed in a random order. That's what unordered. It's not basically like the order we have inserted, because we have inserted 1 2 34 4, but here it's coming 4 34 2 and 1. So this is not, this isn't in our inserted order or ascending order, descending order. It's totally an out of order, that is unordered. So it's coming in unordered, like random. It's not getting in a random order. And another interesting thing in unordered map is that this also doesn't tolerate any duplicates. So we have here inserted 2 ones having same key, and we aren't getting that over here. So this is the like plain difference between map and unordered map. And insertion in unordered map is like really quick, and because here it doesn't perform any sorting, and it like depends upon your use. If you wanted a map to have storage in a form of like sorted order, you can use normal map. And if your use is just I just want to store key and value pairs, I don't care whether it is sorted or not, you can just go and use unordered map, which is very much faster in insertion time than normal map, because it avoids sorting. So this is for unordered map, and let's now go and do for multi-map. So multi-map, it's present in our normal map itself, and here we are just going to type multi-map. That's it. Just paste it and paste it. So if I just execute it now, It's really interesting, and there are like two differences compared to our previous unordered map. Here we are getting 5 key value and value pairs because we are having our duplicate one. So important difference is that multi-map allows duplicate keys. So that's a real game changer in multi-map. And another thing, multi-map sorts the map. Okay, so here it's getting sorted in ascending order based on keys. As I told you, just sees only the keys, not the values. So just getting sorted in keys. So if I just go over here and put greater int over here, so it will sort in descending order. That's it. So all the other like previously used like erase, find, clear, it can also be applied for map. So let me put m.clear over here, and let me just see out m dot size. Okay. So if we just execute and run it, operating size as 0 because this is how the elements, and once declared size it becomes zeros. So this is how you use m.clear, and I will show you m.erase and m.find. Find it's going to be m.find and the key. Okay, you should not pass the value. So it's going to be key. So our key is, let's say, 34 over here, and this basically returns a iterator reference to our 34. Okay, in the map. So we can't just go and print cout m.find 34 because it's not going to give return 1 or 0. It's just going to give the iterator reference. So for that we can store it in a auto variable. Okay, so it's going to be auto I m.find, and using this we can just access our like value present inside it. Like just put I dot first some space, and let's put I dot second. Okay, so if we just run it this now, okay, so we need to put asterisk. Okay, asterisk of I. Here also we will do asterisk of. Okay, so if we just run it now. Okay, so as you can see at the end we are getting 34 and its value. So this is how we can check like whether it's present inside our values present inside our map or not. So for erase, it's going to be really simple. It's going to be like erase m dot erase. Just pass the key. Okay, let me put 1. So let me just copy this and paste it. Let me just put a cout saying after erasing, and let me have handle. So let me just run and see how it works. So as you can see here, we had 1, okay, but it just deletes that particular key. Okay, so and I have inserted 2 once, and as you can know here I'm getting only 1 because it's just a normal map, and it just deletes that one as well. So what if this was another map, like sorry, a multi map, like we put multi map, and let me have this as well as multi map. Okay, so now it's a multi map. So if I just run it now, so basically so here I'm having 2 ones, but it just deletes that 2 ones. So erase function basically will delete all the keys that are having that the element we have passed. Okay, so if it's like it does not occur the first occurrence, okay, it just occurs all the things, all the entries. So it just removes this one as well. So that's it. Hey, hello everyone. So in this video I will be showing you how to use Q in STL C++. So here I'm having a sample code like how to implement Q by using only array. Okay, so it has like nearly 90 plus lines. Okay, so this is by using array, and with the help of STL in C++, this 90 lines can be like replaced by only 5 lines of code. So that's it. That's what I'm going to show in this video. So let's get started. So for first implementing Q, we need to include #include Q. Okay, because Q is a container, so it has directly its name over here, #include Q. So if you want to like include the whole package, you can go with #include bit/stdc++.h. That's your wish. So first let's declare a queue. Okay, so same as vector. So for vector, what we did, we had put vector int the name of the like our vector random variable. So for q also it's the same thing. Instead of vector, just replace with q data type. This can be string, integer, character, anything, and just a name. So it's since we are using q, we will go with the alphabet q itself. Okay, so this is how like we need to declare a queue. So next thing is how we can like initialize the values. So for initializing the values, we will be using q dot push. Okay, so let me push 100 first, and let me put q dot push of 20. So this is also like quite similar, because in vector we will be using q vector dot pushback. Here we are only limiting to push. Okay, so q dot push of 10. Okay, so how q works is basically is that q is a first in first out algorithm. Okay, so let's consider this is our q, consider this as our container. Okay, so here we have pushed three elements. Okay, 100, 20 and 10. So 100 will be stored in the first, 20 and 10. So it's basically first in first out. Okay, so what if we wanted to delete delete element? Okay, suppose if we want to delete element, we can't delete this last one. Okay, we can't delete 10 because as the name suggests, q is first in first out, so only the first element can be removed. So if we put pop, okay, pop is the function for deleting. If we put pop q dot pop, it will remove 100, and once again if you put q dot pop, it will remove 20, and once again if you put q dot pop, it will remove 10. It won't remove the element from back. Okay, it will always remove the element from front. And another thing is, if you put q dot push, okay, push, it will always push the element at the last. So suppose if you want to put q dot push of 5, q dot this will go over here. Okay, it just gets added at the end. It won't disturb at the front part because it's first in first out. Just imagine if you're standing in a queue. Okay, so the person who comes first stands at the front. Okay, and the person who comes late just gets along at the back of the queue. So just the queue just goes on extending to at the end. Okay, the first it's just the order of the people how they come. So same thing, it's just the order of the numbers or the strings or the particular data type how it's inserted. Same thing over here, it's first in first out. So pop, it will remove the first one, and push, it will get inserted in the end. And we have front and back. Okay, and there is another thing, what if we wanted to insert a particular element in the front? So in that case you can use something called as Deque, which is also a container present in STL. I will do a separate video on this. The By using Deque we can like, here we are able to only remove the front element, right? By using Deque we can remove the back element as well, and we can insert at the front position as well. So it's like multiple ways. It's called as Deque. I will take it in a separate video. So now let's come back to queue. Okay, so let's see how we can like display the contents present in our queue. Okay, so for that what we will do is we will be using q dot empty. Empty is the function. Okay, so let me just put first cout q dot empty. So now our queue is in empty because we are having like pushed three elements. So if I just run this now, I will be getting output as 0. So I'm getting the output as 0, and if I just comment these 3 lines, okay, so which means that we haven't pushed any elements inside our queue. So if I just write down, I'll be getting the output as 1, which means that our queue is empty. So in simple terms, q dot empty returns true if our queue is empty. That's it. And return false if any element is present inside it. So using this and a while loop, we can just get the contents present in our queue. So I'll put while not equal to q dot empty. Okay, and the reason is because we are just going to iterate through the elements present in our queue, and once our queue is empty, we need to just break the condition. Okay, because there isn't any elements to iterate. So here we'll be using not equal to q dot empty, and the code is cout q dot front. Okay, and we have just an end line, and here we'll be putting cout, not cout, just q dot pop. Now suppose this is our queue 100, 20, 10 and 5. If you put q dot front, 100 will be displayed. It does not, it won't delete 100. Okay, 100 will be present in our queue itself. It will just display the value as 100 in the output. That's what q dot front. And we have q dot back as well. So by using q dot back, it will just display 105 as the output. it won't remove 5 from our queue. It's just displaying, that's it. So if we once we have displayed q dot front, okay. So what if we want to display the other elements as well? In queue we can't use that index, okay, like q of 1, q of 2, like we can't use indexing in queue. So the only way to get access to the next element is display the first element and remove the first element. So what will happen is that once we have displayed 100 will be removed. So the next element will be 20. Okay, so display 20 will be displayed and remove 20. Same thing, now next only 2 elements will be there. Display 10, remove 10. That's it. Same thing that I said in that whiteboard. Q dot front, we will be getting the value of 100. And next thing what we'll do, we will just put q dot pop. So don't put cout q dot pop, because q dot pop, it does not return anything, just removes the element, that's it. It's not going to display anything in the output. So q dot front, it just displays 100, and q dot pop just removes it. And again while loop, it will go inside the while loop, and again q dot front 20 will be there, q dot front 20 is displayed, and q dot pop, so 20 will be removed. Same thing, front 10 will be displayed, q dot pop 10 will be removed. Same thing, this is how it works. So now if I just run this now, I'll be getting the output as 100, 20 and 10. And another thing you need to like have in mind is that once you have done this operation, once you have displayed all the contents, your queue will become empty. Okay, so if I just put cout q dot empty, so your queue basically like becomes empty. So if I just run it now, I'll be getting the output as 1 at the end. So I'm getting 1, because which means that the queue is empty. So you need to be careful. So if you have like performed all the operations, make sure that your final operation is displaying the contents present in the queue. So now that's how we are going to display the contents, and we have q dot back as well. So I will go here, I'll just put cout last element is, I'll put q dot back So here we are having 100, 20 and 10. Okay, so I will just cut this code. So we are having 100, 20 and 10. So I will, when I just run this code, I will be getting the last element over here as 10. That's it. Back just gives the last element, and front, if we haven't understood that part, okay, in the printing part, front just gives 100. That is the first element that I have pushed inside the queue. That's it. I'm getting the first element. Okay, sorry, first. I'll just change it. It's a first. Okay, that's it. And we have done with front pop basically just deletes it. So what if now I just remove and put it? So we just put q dot pop. Okay, so this is our normal template for displaying the contents present in our queue. So if I'm just adding another extra q dot pop before this while loop, means it will remove this 100. Okay, it removes first, because as I told you, it's first in first out, 100 gets removed first. So if I just run it now, I'll be getting only 20 and 10 in the output. So I'm getting 20 and 10 in the output. That's fine. And we have like cout q dot size as well, which gives the size present in our queue. That's I'm getting three elements are there. So that's it for this queue. Hey, hello everyone. So today we are going to see about stacks in C++ STL. So first let me begin by like giving a basic definition of what is a stack. Okay, so a stack is a last in first out, okay, container. So consider this as a container. Okay, so it's last in first out. So consider we are pushing one, okay, inside a container. So let's consider 1B here, 2B here and 3B here. So by pushing means that S be our stack. So first we are putting s dot push 1, and then we are doing s dot push 2, s dot push 3. Okay, so this is how we are pushing it. So last in first out. So this is the first in, okay, and this is the last in. 3 is our last in element. So now what if you want to delete an element? Okay, so we'll be doing s dot pop. Okay, so since our stack is a last in first out, 3 will be getting deleted. Okay, and if you again do s dot pop, 2 will be getting deleted, and if you again do s dot pop, then only 1 will be getting deleted at the end. So that is last in LIFO. Okay, stack Q is FIFO, first in first out, and stack is LIFO. So stack is pretty much really simple. It has only like 4 to 5 important functions. One is push for inserting and pop is for deleting, and we have empty to check whether our stack is like empty or whether it has any elements in it, and we have size to check the number of elements present in our stack, and we also have top. So top is basically is used to display the lastly inserted element. So suppose if we had 3 to 1, consider 3 to 1. If we put s dot top, means we will be getting the value as 3 as the output. And another important thing that you need to note in stack is that we can't like access the element through indexes. Like if you put s dot s of 0 means we won't be getting 1 as the output. We can't do that like in vectors or arrays. So for displaying the contents, we need to use a while loop and just do s dot top and s dot pop repeatedly. That's the only way we can get like the elements present inside of stack. So now let's just go ahead and code. Okay, so the header file for stack is hash include stack. So you can use this hash include stack, or you can go with this entire bit slash stdc++.h. So it's your wish. So now same thing as we did for vectors. So it's going to be stack, the data type, the name of our stack. So let S be our name of our stack. So for vector it will be vector int v. For stack it's going to be stack. That's it. That's the difference. So here this can be anything. It can be a string or int or float. Here we're going with int. Okay, so first thing what we can do is we can just insert something. So I'll put s dot push. Okay, for vector it was push back. For stack it's just push. So I'll just push 1. Okay, so now let me show you how it works, the size. So I'll put s dot size. Okay, I'll put cout sizes, and let me have here an endl. Copy and paste it. So here we are just going to put s dot empty. Okay, so let's go for it and see what we will be getting in the output. So here we are getting the output as size is 1 and the s dot empty has written 0. So which means that our stack isn't empty. So if it isn't empty, we'll be getting 0, and if the stack is empty, we will be getting the output as 1. So like if I just make the stack empty now, so I'll just put s dot pop over here. So which means I'm removing that element. Okay, so I'm pushing 1, now I'm popping it. That means the stack is empty again. So if I just execute this now, I will be getting size is 0, and next time I will be getting for s dot empty I will be getting 1. So as you can see, size is 0 and s dot empty is true because our stack is empty. So I'm getting the output as 1. So that's it. So let me just push more elements. I'll put s dot push 2, and I'll put s dot push 3 as well over here. So I will just show you how s dot top works. So if I just run this now, top element is so I'm getting size as well as 3 and top element is 3. So now if I just put s dot pop, I'll be getting both the size and s dot the topmost element will be 2 as well, because 3 is getting removed and size is also getting decreased. So 2, that's fine. So now let's just see the final one, like how to display the contents present inside our stack. So for that we will be using a while loop. Okay, so while we are just going to print the contents present inside our stack until it gets empty. Okay, so once it gets empty, we need to stop the while loop. So for that we will be using while. So stack shouldn't be empty. So s dot empty. So this is our condition. So if the stack isn't empty, we will be running this while loop continuously, and if the stack is empty, it will return 1. So if this becomes 1, this is not operator, so it will be 0. That's basically how it works. So if it isn't empty, s dot empty will return 0, not operator will make it 1. So while loop will be running. That's simple. So what we will do here is we will do cout. Let's just give some space and let's just put s dot top. Okay, and next slide we will be doing s dot pop. That's it. So by using this we will be getting like the contents present inside our stack, and how it works is basically is that our stack will be like this. So let me just draw it over here. Okay, so our stack will be like 1, 2 and 3. So the first thing is s dot top. So what will happen is that cout s dot top. So in my output over here I will be getting 3. Okay, 3 will come first, and next thing is s dot pop. So 3 will be getting removed, and this condition will be checking whether my stack is empty, and my stack isn't empty. So what happens is that again s dot top will work. So I'll be getting 2 over here, and s dot pop. So 2 will be removed. So same thing, it will check whether it's empty, then 1 will be displayed and 1 will be popped, and at the end our stack is empty. So this condition breaks over here, and that's it. While loop terminates. So this is how it works. So now let me just run this first. And I'll go to I'm getting 3 to 1. That's fine. And another important thing is that now if you do cout s dot size, and if you put cout s dot empty, we'll basically see that our stack is empty now. Okay, so as you can see here, okay, so 0, 1, okay, these are the values. 3 to 1 are the contents present inside our stack, and 0, 1, so 0 corresponds to the size and 1 corresponds to the empty, that which means that our stack is empty. So while printing, what it has done is that it has just basically emptied our entire stack. So I would like recommend you to copy our contents present in the stack inside another stack, or you can use this condition at the end so that your stack gets emptied once you have completed all the necessary operations. Hey, hello everyone. So today we are going to see about Deque in C++ STL. So first let's see about what is Deque and why it is used for. So let's go to the whiteboard. So you can call Deque as an additional functionality added to a queue. Okay. So for example, consider a queue. Okay. So let's say this is our queue, and it has like 1, 2, 3, 4. Okay, that's 4 elements in it. And the problem with queue is that you can only add elements at the last. Okay, suppose I'm doing qb over queue, I am putting q dot push 5, means that 45 will get added only at the end over here, and it can't be added at the start beginning. Okay, because queue is first in first out. And if I do q dot pop, I'm going to get 1 as the output. Okay, 1 will be removed from my queue, and I can't also delete the last element. I can't remove 5. So in order to remove 5, I need to remove 1, 2, 3, 4, and then only I can pop out 5. So these are like some of the disadvantages present in a queue. So in order to like give more functionality, we have got Deque. Okay, in Deque we can also insert the element in front and insert the element at back, delete the element in front, delete the element in back. So the disadvantages in queue is addressed in Deque. That's it. It's really pretty much simple. It's kind of like a mix of a vector and queue. Like, so now let's get to the code. Okay, so for Deque it's going to be as include Deque, or you can just go over with this one, this header file, or you want to be specific, you can go with as include Deque. So for declaring a Deque container, it's going to be Deque int. I'm going to use an integer data type over here, so int, and let d be my Deque over here. So first thing what can we do is let's go with pushback. Okay, so d dot push underscore back, we put 1, and let me just copy this, paste it, and 3 and 4. Okay, that's fine. And as I told you earlier, Deque, the contents present in the Deque can be accessed by using an iterator. So let me go for an iterator over here. So copy this, paste it, iterator. And another thing is you need to keep in mind is that if you are using only this as include Deque, you need to use as include iterator as well, because it isn't present inside Deque. Okay, so let it be our iterator, and let's just put a for loop over here. For it equal to d dot begin, it not equal to d dot end, it plus plus, and just put a cout, some space, and asterisk of it. That's it. So we're just iterating through it. Simple iterator concept over here. We're just pushing and we're just iterating through it. So now let me just run this code. So as you can see here, I'm getting 1, 2, 3, 4 in the output. So here I have used only d dot pushback. So now this is basically like 1, 2, 3, 4 is pushed in a linear fashion. So now what if I do with d dot push underscore front? Okay, so this push underscore front is only present in this DQ. It isn't present in vector as well. So d dot push underscore front, let me put 5 over here. So you can't do this in Q as I told you earlier, because push front means our 5 will be coming over here. 5 will be over here. 5, 1, 2, 3, 4 will be having that, but this can't be done in Q, because in Q, as I told you earlier, it can be done only at the end. So if I put push front 5, will be having the output as 5, 1, 2, 3, 4. So as you can see, I'm getting the output as 5, 1, 2, 3, 4. That's fine. So we have like options to access the first and the last element. So for that, it's going to be cout front. Just go and type d dot front and I enter. And for accessing the back element, it's going to be cout back d dot back, and that's it. So you'll be getting the front and back element by using that. So we'll be getting 5 as the front element and 4 as the back element. That makes sense. And next we have some of the common, like we have pop back and pop front as well. I will be doing that as well over here. So for pop back, let's go over here and type d dot pop underscore its back. Just put a cout after deleting, put a handle, and let me just copy this over here. So just run it down. So this is like we are popping it back. So 4 we are having 5, 1, 2, 3, 4, and after deleting we can see that pop back removes the last element from the end. So 4 is getting removed over here and we are getting 5, 1, 2, 3. And if we just copy this one and like do it twice, let's have a cout handle over here as well, and I'm just popping back twice. So what will happen is that 3 and 4 will be getting removed. Okay, so as you can see here, 3 and 4 are getting removed because I have used pop back twice. So now I've just remove this and I'll put pop front. Okay, so that's what the great advantage by using DQ. We can delete at both the ends, insert at both the ends. So as you can see here, I am pop front deletes 5 because it's the frontmost element. And another thing with DQ is that you can also get the access of a particular element. So let's suppose say I want to get access of the second index present in this DQ. Let's say suppose say I will put d dot at, and I will specify here 2. So which means that I need a second element present inside my DQ. Okay, so for that, let's see what we get the output first. So I'm getting 2, that is the index number 2 because it starts from 0, 1, 2. So I'm getting 2 over here. So now what if I go over here and put 0 and execute on it? I'll be getting the output as 5 because it corresponds to the index percent. So it starts from 0, okay? So 0, 1, 2. So it works that way. So these are some of like the additional functions that are used by using DQ, and there are also like some regular ones like clear, we have erase, we have insert, and we have swap. So these are like some of the commonly used functions. These are like common for all things, for all containers vectors. So same applies for DQ as well. Hello everyone. So in this video we are going to see about priority queue in C++ STL. So let's get started. So first let us discuss about the functionality of a priority queue. Okay, so the priority queue works based on heaps. So there are two types of heaps, min heap and a max heap. So heaps are nothing but a tree like data structure. So as you can see here, consider this min heap. Okay, so 10 is the root node, which is the smallest element, and it's as well as the parent element to 11 and 20. So it works fine. And consider 11. 11 is a parent element for 40 and 30, and it's the smallest element, parent element. And 20 is also parent element, and it's smallest when compared to 50 and 60. So this is a min heap. Same case applies for max heap as well, but only difference that the parent element should be a larger number than its children. So 100 is a root node. It has children for the 50 and 30, so it's larger than that. And same case for 50 and 30 as well, they are larger than the children. So priority queue makes use of this property. Okay, so based on that, we can implement both min heap and max heap in priority queue as well. So let's suppose say I want to get the largest number from a container. So let's suppose say I want 100. Okay, so consider this as some container data structure. So I want 100, so I get 100 and delete it. So next thing I will be getting is 50. Okay, so priority queue can be used in case if you want to just keep on extracting the largest number from a set of values. So once I've extracted 50, I will be extracting 30. So this is how priority queue works, and same thing applies for min heap as well, minimum priority queue. So in case I want the minimum smallest element, I will get 10 extracted, and then I want to find the smallest among the remaining elements, I will be getting 11. So 11 will be extracted, then omitting this 11, we need to find the smallest among the rest of the elements. So I'll be getting 20. So to extract the smallest or the largest number from a set of values continuously, in that case we will be using priority queue, and I think it is really efficient than sorting itself. So that's when you use a priority queue. So let's just go to code. Okay, so this is really fun coding. Okay, so first let me put you need to import the header file as include bit slash /std. That's fine. So after that, it's same thing, priority underscore, you need to use underscore queue, and you're just putting a data type. I'm putting it, and let queue be your priority queue. And for pushing values inside priority queue, it's going to be queue dot push. That's it. So let me just put 10 queue dot push 0, and by default it will be a max heap or max priority queue. So we will be getting this order. It will just, like if you're extracting 100, like that is if you're extracting any value from the container, it will be a maximum value. Okay, so I put queue dot push, I'll put 20, and queue dot push, I will put -1. Okay, so like have a balanced number. So now I put cout queue dot top, which is like the topmost element or root element, we can like imagine in that. So if I just save and run it now, I will be getting 20 in the output, because by default this normal priority queue will be a max heap. Okay, so it will have the functions of max heap. So I'm getting 20, and there is also like another function queue dot size as well. Same thing, if we just run it, I will be getting the size as 4. I'm getting 4. Now let's delete an element. Okay, so same thing for deleting it, it is queue dot pop. So as I told you in this example, it will delete the largest element from the set of values. So in our case, our largest element is 20. So 20 will be now removed completely, and after removing 20, if you put cout queue dot top, it will go on to the second largest element, which is 10. Okay, so as I told you, exactly same. So if you just remove 100, 50 will occupy its place. 50 will be considered as the largest element, next element or the top element. So if you remove 50 as well, 30 will be considered. So that's how it works. And here now I'm popping out 20. So 20 will be just removed from it, and will just consider which is the largest element among the remaining elements. So 10 will be going over there. So if I put queue dot top, I will be getting 10 now as the output. So I'm getting 10 as the output. I hope that made sense. And let's do for a min heap or a minimum priority queue. Okay, so for that, what you do is you just put a comma, and you need to add vector int and comma greater int. Okay, so usually we will only add greater int, we won't be adding vector int. So in this case we need to add vector int as well. So now let me just comment this one. So now if I just would do queue dot top, I'll be getting -1 as the output, because as you know, it's going to be like min heap, so minimum value will be getting popped up. So I'm getting -1 in the output. And if I just now remove this, I'm doing queue dot pop and then queue dot top. So what happens is that queue dot pop, okay, so -1 will be removed, and next the smallest element is 0. So same thing, we are removing 10 over here. The next smallest element 11 occupies its space. Once 11 is extracted and removed, 20 occupies its space, and this keeps on repeating. Same thing goes here as well. So once -1 is gone, 0 will occupy its place, and 0 will be the new top. So if I generate now, I'll be getting 0 in the output. So I'm getting 0, so that works fine. So last thing, we need to just display the contents present in our cube. Okay, simple. So let me just remove this. Same thing. This is only going to be the process. We need to do this q.pop and q.top continuously till our priority queue becomes empty. That's it. So let me just put a while loop over here. While q.empty. Okay. So q.empty returns true only if our priority queue is empty. Okay. So q.empty returns true only if our priority queue is empty. So now this case it will return false because our priority queue isn't empty. So what we do is we need to put a not operator, which means that this process will be keep on repeating until our our priority queue becomes empty. So if our priority queue becomes empty, q.empty will return true and this not will convert that to false and the while loop breaks. But in normal case, when priority queue has some values, q.empty will return false and not converts to true, which makes our while condition satisfied. I think this is like basic. Okay, really simple. I explained it well. So now just put it inside it and insert and just give some space to display. So and another important thing is that q.top should come first. Okay, so if you are doing q.pop first inside this while loop, one will be getting removed and one won't be getting displayed, because if you do q.pop first, one is removed and we will be getting 0 in the output at first. So one will be like not getting displayed in the output at all. So simple thing, you need to just cut this and paste it over the top, and now just let's run it. So we'll be getting in ascending order. Okay, so -1, 0, 10, 20, that's fine. And now if I just go over here and like the standard max heap, just removing this, saving it and running it. 17, 20, 10, 0, -1. So that's it. Hey, hello everyone. So today we are going to see about swap in C++ STL. So swap is basically just to interchange the values present inside variables. So currently we have here the traditional swap method where we use a third variable. So this is a temporary variable. So I'm having t as a temporary variable and a is 5 and b is 10. So same thing. And if I just run this code, we'll be getting a's value as 10 and b's value as 5. Just the value gets interchanged. So as you can see here, a is 10 and b is 5. So this 3 lines of code basically can be replaced by 3 lines, and plus this temporary variable can be replaced by this swap function, and this swap function is present inside this bit/hdc++.h. So you can just go over here and put swap a comma b. That's it. And if you just run this code now, we'll be getting the same output as well. A is 10 and b is 5. So this has like multiple uses. For example, let's consider this array. Okay, so let's say int arr is equal to like 1, 2, 3, 4, and 5. So let's suppose say we need to swap the 0th index and the second index. So what we can do is we can just go over here and put swap arr of 0 comma arr of 2, which means that 3 will be coming over here and 1 will be going here. So now if we just put cout arr of 0, we will be getting 3 in the output. Okay, so we're getting 3 in the output because 3 is getting swapped to 0th index and 1 is getting swapped to second index. So that's why we're getting 3, and the same thing can be used in vectors as well. So that is the power of the swap. It's just really simple. It is just swap and just to pass to like 2 elements. And you can also even use a for loop. Okay, in case of like any palindrome or you want to check something, you can just pass I over here and just put inside the for loop. That also works. That's it for this video. Hello everyone, in this video we are going to see about pairs in C++ STL. So let's get started. So first let me tell you what is a pair. So pair is quite similar to map. Okay, so in map in C++ we will be having a key and a value. Okay, map will be having a key and value. So at the end we will be having like 2 numbers or 2 variables of any data type. So by using the key we will be able to access our value. So this is what we do in a map. A pair is also quite similar to a map, but the only difference is that in pair we won't be having a key and a value, but instead we will be having 2 values itself. Okay, that's the only difference. And here we won't be able to access one value by using another value. It isn't the key and value concept like map. Instead we will be having 2 values. That's it. And maps are used independently. Okay, like we can use map independently without help of any other container. But pairs we can also use independently, but mostly pairs are used through vectors. Okay, so first let me just delete this and let me show you the syntax of pair. So it's going to be same thing. You need to import this header file as include bit/std, and for pair it's going to be same as for vectors. It's going to be pair. As I told you earlier, here we will be having two values. So we need to pass any two data types. So here I'm going to consider int. Okay, it can be int or string int, char int, anything of your choice, and int, and let p be my pair. I will put p. So this is like a standard syntax for pairs. So there are like different ways of initializing a value. So this is one way. So if you just go here and put 1, 2, this is, so we are having a pair of values now, 1 and 2. And let's say now how we can access this value 1. Okay. So if we just go and put cout, in map we will be using that particular map dot first dot second. Same applies over here as well. So we will put p dot first and you put enter. And if you just go here, put cout p dot second. So first corresponds to this 1 and second corresponds to 2 within a particular pair. Okay, so let me just write down. So I'm getting output as 1 and 2, and let's suppose say you want to copy the contents present in this pair to another pair. So for that we can do just copy this. I can just go here and put p1 of p. So all the contents present inside p will be copied to p1. So if I just go here and put p1, I'll be getting the same output. Same 1 and 2. So these are like, this is one way of like initializing values to a pair. The other way is like you can also do this way around. And just go here and manually assign p.1, p.first equal to 10 and p.second is equal to 20. So this will also work. And like suppose in vector we will be having, let's suppose v is our vector, we will put v.pushback. For pair we need to do this way. We need to put p equal to make underscore pair 1, 2. Okay. Now, so this is how it works. And let's suppose say we need to have like a array of pairs or a list of pairs. Okay. So I will show you how it's done. So for that what we need to do is you need to like, in case of declaring array, what you do, int year of 100. So similar case here also you need to put pair and the particular data type. And as I like told you earlier, I forgot this to tell you, you can also have like a string over here, and in case of you're doing string, you need to pass bit within double quotes that we put some random text. We just write now. You need to pass within double quotes for string, and if it's of like a char type, okay, of a character type, you need to do within single quotes. Okay. So these are some basic stuff. So now let's jump to our list or array of pairs. Okay. So for that what we will do is, as I told you, it's similar to array. So you need to put p of some n. Okay, n number of pairs that we're going to have. Okay. You just put a random 100 over here. And first we need to get the input from the user. Okay. For that we will be just using a for loop for int I equal to 0, I less than, let me say I'm going to just input 5 pairs. Okay. So 5 pairs means we'll be having like 10 values. Okay. First pair dot first will be 5, pair dot second will be 5, so which may adds up to 10 values. So it's going to be I plus plus. I'm just going to put c in p of 5. Okay, you need to put p of 5. If you put p, it will be error. P of 5 dot. We're going to put first and next p of I dot second. Okay, this is how we're going to get the input. So for like displaying the output, same process. Just copy this and paste it, and instead of c in, just put cout, and here also cout. Just put. Okay, let me just do this way. So mostly no one like prefers using this way around. Okay, like manually initializing value for a pair and using. Everyone just combines vector to pairs. Okay, it's used combinedly. No one use pairs around. So I'm showing this. After this, I will be explaining you about how to like combine vectors and pairs. So this is fine, I guess. Yeah. So let me just add a endl over here. Just put a endl because each pair will be displayed in a separate line. So let me turn it now. So I will be inputting 10 values because I have kept the I value less than 5. So first line it's going to be 1 and 2, and 3 and 4, 5 and 6, 7 and 8, 9 and 10. So I'll be getting the same as output. That's fine. So now let's see how we can do pairs, how we can combine pairs and vectors. Okay, so vector pair int of the data type, and v the name of our vector pair. So this is the syntax, and we're getting input. We need to like change this a bit. Okay, so it's going to be, let's say our input is going to be, let us have like two variables. So int a comma b our input values. So it's going to be cin cin of a and cin of b. And next line what we'll do is we'll do v dot push underscore back, and here we'll be passing kind of make underscore pair of a comma b. There's also multiple ways of doing this. I will show you now. So this will work, I guess. So let me just reduce the number of values. We put 3. Let me run it now. So I put 1 and 2, 3 and 4, 5 and 6. So it works perfectly. And like instead of doing this on a repeated basis, you can just simplify this code as you can do just a curly bracket, and you can just go here and do a comma b like this way. So this will also work. So let me do same stuff. That's working perfectly as well. Hey, hello everyone. So today we are going to see about Valarray in C++ STL. I think it is one of the most least used containers in STL, but anyway, it's really useful and we can learn about it. So let's get started. So what is Valarray first? Valarray is a container which is quite similar to arrays, normal arrays, but with additional functionality for mathematical operations. For example, we used to do some of the basic mathematical operations like to find the sum of an array, sum of all elements in an array, find the minimum elements in an array, maximum elements, perform shift operations. We will be using a for loop, and we need to have so many procedures for using this, like doing some minimum, maximum, etc. But by using Valarray, all these operations can be done by just assigning it as a function. So that's the advantage. It just reduces our operation time and the codes for doing that operation, because it replaces all the codes as a inbuilt functions. So let's get started with Valarray. So I will just delete this one, and you can go with the header file as include Valarray, or you can just comment this out and use bit/stdc++.h. It's absolutely your choice. So let's get by declaring a Valarray. Okay, it's going to be Valarray, and it's going to be of type int, and let me put vr be my Valarray va, okay, equal to 1 comma 2 comma 3 comma 4 comma 5. So let me start with a minimum and maximum element. Okay, so for finding C out, let me put min space, and I will be putting va dot min, just a function. So this will give us the minimum element present in the array, and I'll just copy this, paste it again, and I'll go and put here max, and I will just change it as max. So if I just run it now, so min is 1 and max is 5, so that's right. So let me just try it for a normal array whether it will work or not. So I'll put int arr equal to 1 comma 2, and we just copy this, and if I just go over here and type arr, no, it's not working for a normal array. So it's only confined to this. All these inbuilt functions are only confined to our Valarray. Okay, so next what we can do, so next we can do sum. Okay, let's just find the sum. So we'll just put endl, here also endl, and same thing, just copy this again and just put sum. So for sum, finding sum in normal array, we need to use a for loop. Okay, we need to use a for loop and have a temporary variable sum equal to 0 and just iterate through the elements, but here it's just replaced by a single line of code. So let me run it now. What's the sum actually? It's 3, 6 and 15. So 15, it's working perfectly. And another thing is like a really important operation. Suppose what if we want to increment all the values or all the numbers by particular value. Let's suppose say I want to add 2 to all these numbers and store it in another array. So we can also do that. So for that, what we need to do is we need to have a temporary Valarray, okay, for storing the values. So it's going to be va1. So how it works is that va1 equal to va dot apply, and inside this apply what we need to do is we need to put this square brackets and you need to pass int x, which basically represents all the elements, int x, and we're going to put a return x equal to x plus 2. That's it. So this is the code over here. So now let me print the contents of va1. Int I equal to 0, I less than va1 dot size I plus plus c out. I'll put va1 of I. So as you can see here, I'm getting 3, 4, 5, 6 and 7, which means like what it does basically is that it takes all the elements of VA, that is this array, and just adds 2 to each element. So 2 is added, so it becomes 3, 4, 5, 6 and 7 and just stores in VA1. So I'm just printing the contents of VA1, so I'm getting the output, all values incremented by 2. So it's really simple over here. We can use this apply and this simple function to do this work. And next thing what I'm going to do is I'm going to use the shift operation. Okay, it's really the same code as well. va1, the temporary Valarray, va dot shift, then just pass a number. So what this number basically means that if the number is positive, it shifts in the left side. So here we are having positive 2, so it shifts our array twice left, and if the number is negative, it shifts in the count of time in the right. So that's what it's going to do. So here we are going to do shift our array twice in the left and just going to store in va1, and we are just displaying the contents present in va1. So now if we just run this code, we're getting the last 2 elements as 0. That is because we are just removing the first 2 elements. That is what normal shift does. Suppose what if we want to have 1, 2 here instead of these zeros. So for that also there is option. We can go with circular shift, C shift, and if we just now execute it, it performs the same thing. It performs the same left shift, but instead of removing those 2 elements, we are having 1 and 2 over here. So it's really useful. Suppose what if I gave here minus 2. As I told you earlier, minus refers to right shift operation. Okay, so if I just run it now, so it's basically shifted twice in the right shift is performed twice. That's what done over here. And if I just go and remove the C shift and perform it as a normal shifting operation, we will be getting zeros at front of the array. Okay, so I'm getting zeros at the front of the array. That's fine. And the final function what we have over here is that swap. So if I just go over here and put va1 of 6, 7, and if I perform va1 dot swap va, just run this code now, I'll be getting 1, 2, 3, 4, 5, which is basically va1. I'm printing va1, so va values comes to va1. That's what it's working done over here. And I hope you would have found this video useful, because Valarray, I guess very few people use that. I've never seen anyone using that, and I actually surfed the web to know what the Valarray is. So hey, hello everyone. So in this video I'm going to show you how to find the minimum and maximum element present in a vector by using only one function or one line of code. So here I am having like a standard method how you used to find minimum maximum element present in a vector. So here's the vector, and we'll just assign some first element present in a vector to min and max, and we'll just use a for loop and iterate it. And if any element is lesser than that, we will just swap it to the min, and same thing with the max. If any element is greater than that, we just put it in the max. And if we just run this program, we will be getting the minimum and maximum element. Okay, 5 and 1, so that's good. So here we are just going to replace this entire code by a single function. Okay, so I will just go here and delete all those. Let's int max comma in. Okay, so it's going to be max equal to asterisk max I underscore element, and here we'll be passing the starting, begin and end. Okay, so it's going to be a dot begin and it's going to be a dot end. So this returns the maximum. Okay, maximum element. So I'll just put C out and I'll put max. So you have to put asterisk. Okay, you have to be careful over there. If you aren't going to put asterisk, it will give you an error. So it's going to be 5, and if you just copy this, okay, copy and paste it, and then you need to change to min. Okay, min, and for max, in the place of max, you're just going to put min element. That's it. Same code. We just and this you're going to get 5 and 1. Okay, just put endl. So it's also going to do the some backend computations to like find the minimum maximum limit. It's going to take the same time complexity as we are doing using a for loop, but it saves time in case if you are doing contest or something like that. Instead of writing this for loop and looping all takes some time, you just directly put this a vector and can just use these functions. It saves you some lines of code and time. Okay. Hey, hello everyone. So this video I'm going to show you the easiest way to sort an array in C++. So instead of writing like the bubble sort code, quick sort code, you have like so many sorting algorithms. Instead of writing bunch of codes, you can just use this simple function to sort your array in just 3 lines of code. So let's get started. So first let me declare an array, okay, in ARR. Let me have some random values in it, 6, 3, 9, 10 and 1. I have 2 also, okay. So the first thing what we need to do is we need to get the length of our array. So in C++ we don't have any inbuilt function to get the length of the array. So we need to find it manually. So let L equal to, it's really simple, okay, size of ARR slash size of ARR of 0. So what it means is that in our array, okay, each element has 4 bytes, okay. So this one is 4, 4, 4, 4 and 4. So our size of ARR will give us 6 into 4 because we have 6 elements and each one occupies 4 bytes. So it's going to be 6 into 4, 24. So this one is going to be 24 and this one is going to be size of only the first element, okay. It can be any element. We can take AR of 1, 2 random element. So for like, because the size is going to remain the same 4 bytes, okay. So what happens is that we are going to divide the entire size by a single size. As the sizes are same, we will get the total number of elements present in the array. This is the simplest way to find the length of an array in C++. So here it's going to be 24 by 4. We will be getting L as 6. So as I told you earlier, for sorting the array, it's going to be sort. And here you are going to pass ARR, only ARR. This is like an address, okay, just ARR. And this is a starting value and ARR plus L. This is the ending value. Okay, and for the sort function to work, you need to import this header file as include bit slash stdc++.h, otherwise you will be getting an error. So now I'll just print it, okay, print our array for int I equal to 0, I less than, and use L, I plus plus, and I'll just put cout error of I and just print it. So if I just run it down, so as you can see here, my array has been completely sorted. And what happens is that this is a starting portion, okay. This basically corresponds to the 0th index of our array, and this corresponds to the 0 plus L, okay, till the ending -1. So you have like the for loop over here. We have like it's going to start from 0 and I less than L means it will stop from 0 to L -1. Same thing, it starts from ARR 0 and the last index -1. So we are passing L is going to be 6, okay. If you want means I will just print out cout L, okay, cout value of L, and I will just put L, okay, just put endl also, just run it. So as you can see here, I am getting cout value of L as 6. So what happens is that it's just going to be ARR till ARR of 5 index, okay, because it starts from 0. So 0, 1, 2, 3, 4 and 5. So suppose if I want only a particular, like let's say I want only the first 4 elements to be sorted. So in that case, I need to put in ARR, ARR of instead of L, I will just put 4. So this basically corresponds to ARR of 0 till ARR of 3. So we will be getting 6, 3, 9 and 10. Our 1 and 2 won't be getting sorted. So we will be getting the output as 3, 6, 9, 10 and then 1 and 2. Okay. So as you can see here, our first 4 elements are getting sorted and last 2 elements are getting neglected because of our value. So you can just play around with this. It's really cool. It's the easiest way but not the fastest way, because sort function also performs some n log n operations, because the inbuilt function it performs this operations in the background. The quickest sorting algorithm is n log n, like merge sort, and we got other sorting algorithms as well. So it's n log n in time complexity. So it's not the quickest, but it's the easiest way you can reduce your code length instead of just thinking and typing it around. Hey, hello everyone. So in this video I will be showing you how to copy the contents present in a stack or queue into another one in C++. So let's get started. So let me declare a stack, okay. Stack of int, let A be our stack, okay. So let me just push some values into it. So let me just push 1 and let me just push 2 and 3 as well inside it. So 2 and 3. So that's fine. So stack can be like easily copied to another stack by just assigning it. So it's like, suppose we have two variables A and B. So what will you do to store B inside A? So basically you will do A equal to B. That's it. So same thing applies for stack also. So you just copy this, put over here. So it will be going to be stack B, and what you do is B equal to A. So what this does is that all these values will be now stored inside B as well. So let's check that. So let me just print the contents present inside of B. Okay. So while not of B dot empty and C out B dot top B dot pop. So this is how we will print the contents present in a stack. So let me put some space as well. So let me just write it down. Getting 3 to 1 because like whatever element you push at first will be like at the bottom of the stack. So 1 is at the bottom, 2 second most, and 3 is at the top. So that's how it works, and I'm printing the contents present inside B. Okay, so this works fine. And there's like another way you can do this, but is to swapping. But if you perform swapping, it actually just changes the values present inside the original stack. So for example, if you put swap of A comma B, it just swaps the content present in both the stacks. A's content will be stored inside B and B's content will be stored inside A. So what this does is that our A will be empty. So that's the problem by using swap. Suppose if you aren't interested in the contents present in A after like swapping, you can obviously use this way also. So it's just basically the same as well. So if you just copy this and run it, I'll be getting the same output. But another fact is that now if I just go over here and if I just print C out A dot size, okay, so if you put A dot size, we'll be getting the output as 0 because we have swapped. So B is actually like an empty stack. Okay, at first we have only A has 3 values. So after swapping, B empty value gets stored in A. So A becomes empty now. So I'm getting A dot size. So in case if you aren't worrying about A's content after swapping, you can use this one. And for Q also it's just pretty much the same. Just for example, for Q, just go here and change it to Q and just assign B equal to A and just use a while, same while loop, while B dot empty C out B dot front, I guess front is the keyword, B dot pop. So I'll be getting the output as 1 2 3 because Q is first in first out. Okay, B dot empty, and I will be getting the output as 1 2 3. So 1 2 3, I'm getting the output as 1 2 3. So that's it for this video, and I hope you have gone through all these topics and found this video useful. And I've also done many other programming videos in C, C++, Java, Python, as well as SQL queries, as well as interview questions, as well as in Node.js and web development. So if you're interested, also you can check other videos of my channel. Subscribe and support me. It helps me a lot. And thanks for watching.